right, pre-algebra students, today we are moving into graphing non-proportional relationships. So to be successful with this lesson, you should be able to interpret the graphs of linear non-proportional relationships in slope-intercept form. In this lesson, we will be writing equations of linear relationships. We'll talk about the equations of horizontal and vertical lines. We will practice with writing equations of graphed lines, and we will analyze graphs. So make sure you have your guided notes out and ready to go. And let's get started. So when we write equations of linear relationships, basically lines on a graph, we have to understand there are two main pieces of information. There's the slope, or m, and remember slope is just your rate of change. Slope is rate of change. This could be a unit rate. This could just be a rate in general. We also have to have the y-intercept. The y-intercept, or b, in the equation. And we remember from last time that the y-intercept is where the line crosses or intersects with the y-axis. If the graph is proportional, we know the equation will be written in the form y equals mx. Y equals slope times x. And we know the y-intercept will be 0. That's why there is no b here, because b is 0. However, if the graph is non-proportional, the equation will be written in the form y equals mx plus b. And this equation right here, y equals mx plus b, is slope-intercept form. Basically, this is saying the equation of the line is showing in plain detail the slope m and the y-intercept b. So when we think of equations of horizontal lines, in a graph of a horizontal line, meaning a flat line, the y value is constant. Therefore, equations of horizontal lines will always begin with y equals a number. So let's say I've got this equation, or this graph here. I've got a flat line here. Well, this equation is going to start with y equals, but I need to know what the y value is. So for every x value on this horizontal line, I know that the y value is going to be 3. So at this coordinate, this is 1, 3. You've got 3, 3. You have negative 4, 3. All of the y values are the same. So this equation is y equals 3. In the graph of a vertical line, the x value is constant. We're changing it up here. Therefore, equations of vertical lines will always begin with x equals a number. So for instance, let's say I've got this vertical line here, as vertical as I could get it, and I notice that all of the x values are the same for whatever y value we have. So here's the coordinate. I've got negative 3, 2. Down here would be the coordinate negative 3, negative 3. In all of these coordinates, the x value is negative 3. So the equation of this line would be x equals negative 3. So let's practice a little bit. So I'm going to, given the graphed line, write the slope, the y-intercept, the equation, and tell whether the graph is proportional. So on number 1 here, the easiest part of this line to identify is the y-intercept because it's the place where the line crosses the y-axis. Here's my y-axis, right, the up and down axis. And I can see the line crosses right here. The y value of this point is 4. The coordinate is 0, 4. So the y-intercept is positive 4. The slope, we could do one of two ways. We can choose 2 points on the line, so the y-intercept and let's say this point, and find the rise over run, or we can use slope formula. I'm just going to do rise over run this time. So to do that, I'll draw a right triangle between my points. The rise is from 4 to 6, so that's a rise of 2. The run is from 0 to 2. So my slope is 2 divided by 2, which is just 1. So I have a slope of 1, a y-intercept of 4, and my equation would be y equals x plus 4, or 1x plus 4. You don't have to write the 1 here. Oftentimes you're going to see this equation written as y equals x plus 4, but either way is the same. Now, is this graph proportional? No, it's not, because the line does not pass through the origin. The line passes through the point on the y-axis 0, 4. This line could be proportional if it passed through the origin here. So is it proportional? No. Let's try out this next one. Here we have a vertical line. And remember how I said that vertical lines always start out with the format x equals a number. So we just need to identify what is the constant x value here. Well, let me choose a few points. So I know that this coordinate up here would be at -6, +6. I know that this coordinate here is at -6, 0. And this far bottom one would be -6, -8. Now, what do all of these coordinates have in common? Well, their x value is always -6. So in any vertical line, the equation starts with x equals. In this case, it would be x equals -6. Now let's talk about the slope and the y-intercept for a second. The slope of this line, as we remember, for all vertical lines is undefined because it has a rise of any number and a run of 0, and we can't divide by 0. That's why it's undefined. Now the y-intercept is also pretty interesting. This line doesn't cross the y-axis at all. It's going vertical. It will never touch the y-axis. So there is no y-intercept. So that's why the equation is x equals -6. And is this graph proportional? Also no, because it doesn't pass through the origin. For additional practice with this concept, try out problems 2 and 3. Now let's try analyzing a graph. So we're given a graph, looks like it has a negative slope here, and we're asked to find out which of the following situations could be modeled by the graph. So for A, Elena has $100 in her bank account. I'm just going to underline as I go here with some important information. She has $100 in her bank account. Every 3 days, she saves another $10 and adds it to her bank account. The second situation, Hunter weighs 100 pounds and his goal is to gain weight for football. He gains about 10 pounds every 3 weeks. Final one, Dawn's pond is 100 meters deep, but her city hasn't received much rain. As a result, the pond level decreases by 10 meters every 3 days. So here I wanted to highlight some of the important information. If you're saving money, that indicates a positive change. If you gain weight, that is a positive change. If a pond level decreases, that is a negative change. So let's look at this graph for a second. I see that the y-intercept is labeled right here. So my y-intercept, B, starts at 100. My line starts at 100. And if I identify the slope, let's see, let's pick 2 points next to each other. And let's look at the rise over run. So slope, looks like my rise is 10. My run is 3. And my line is decreasing from left to right, so that's a negative slope. My slope is negative 10 over 3. So let's go back to these situations and look at which ones had a positive or a negative slope. The first one, it looks like Elena is saving $10 every 3 days. So I can't say that this graph represents this relationship because it's a negative change, not a positive one. Hunter is gaining 10 pounds every 3 weeks. That's a positive change. It doesn't represent what's on the graph. And last one, the pond level decreases by 10 meters every 3 days. The rate is 10 over 3 and it's decreasing. So I would say this situation accurately represents this graph. For additional practice with problems like this, try out number 6. So that is it for our lesson about graphing non-proportional relationships. Make sure you try out some of the additional practice problems and check your answers with my filled in notes and ask for support in Math Help Desk if you need it. Thanks again for watching.